皆さん、こんにちは。今日は、連
Good
続ウェビナーシリー
afternoon.
ズ
Ladies
日本
and
におけ
gentlemen,
る
thank you very much for
2028 年
attending
建築物 LCA
webinar
義務化に
series
向けて
preparing for
というウェ
Japan's
ビナーシリーズを
2028
始めたいと
Building
思います。
LCA mandate.
同時通訳のご案内です。
Announcement on the
言語の
simultaneous
切り替えは
interpretation
画面上
service.
の通訳をクリックしてお
And
選び
please
ください。
click in webinar control to select the language if you would like to listen to the simultaneous interpretation
改めまし
service.
て、自然エネルギー財団の岡田です。
Once again,
自然エ
my
ネルギー
name
財団と
is
は、日
Okada
本にお
with
け
the
る
Renewable
2028
Energy
年度の建築
Institution
物 LCA 算定
for
報
the
告制度
building
の導入に向けてテー
LCA
マに
to under the
海
theme
外
of
で建
introductions
築
of
物
this new
LCA の実
building
務に携
LCA
わる専
mandate.
門家をお招きし、
We
その経験や
are
知見を
inviting the
伺うウェビナー
practitioner
シリーズを
involved
開催してい
in
ます。
the building LCA to
第1
hear
回は
their
7
knowledge
月7日にフランス
about
の実
this
務者をお
area.
迎えし、
And
フランスの RE2020 を
we
中
have
心
heard
にお
from
話しい
the
ただきました。
expert from France
こ
to
のウェビ
hear
ナ
the
ーは現在
practice
財団のウェブサイトから 録画をご視聴い
from
ただけます。
the France,
ご視
and
聴
you will
さ
be
れた
able
い
to
方は
hear the
今チャッ
recorded
トにリ
version
ンクを貼りま
of the
すので、
past
そこから
seminar, and there is a
ご視
link
聴してくだ
available.
さい。
So that is how you can access
そして
to the
本日は
past
第2回とし
sessions,
て
and
イギ
this will
リス
be
か
the
らスピー
second
カーをお迎えして
time,
いま
and
す。
we have a speaker from the UK.
はじめに建築物の LCA とはというとこ
First
ろ
of all,
で
what is the
簡単にご
building
説明したいと思い
LCA?
ま
Let
す。
me be brief
建
in
築物
covering
LCA
this.
とは建
Building
材の原料
LCA
採取や製造運搬施工から
is
建物の使用回収解体廃棄に至るまで
from the
建築物のライフ
disposal
サイクル
to the
全体にわたる
implementation
環境負荷を調査
to
す
the
ることで
extractions
す。
and transportations,
この
everything.
ライフ
This is
サイク
to
ル全体
assess
の炭素を排出量ホールライフ
the
カーボンと呼
building
びます。
LCA, and this is referred to
こ
as
の
the
緑
whole
のと
life
ころがホールライ
carbon.
フカーボンです。
And what is
ホールライフ
written
カーボンは
in
大きく
green
2つ
is
に分けられて、1つは
whole
建
life
物の運
carbon
用
that
中
can be
に使用
divided
するエ
into
ネルギ
two.
ーなどに伴う
One
オペレーショ
is
ナルカ
the
ーボン。
operational
もう一つ
carbon,
は
which is
建
the
材
energy
製造
used
運
during
搬
the
施
operations
工
of the building.
回収解
The
体など
other
に
one
伴うエンボ
is
ディドカーボンです。
embodied carbon from the extractions,
日本
as
では
well as to the
2028
installations
年
and
か
so
ら
forth.
塗
From
り床面積5000平
2028,
米メートル以上の建築地を対
5,000
象にし
square
て、ライ
meters
フサイ
or
クル全
more
体
of
の
the
温室効果ガ
area
ス排出量の算定報
shall
告制
be
度を導入す
assessed
ること
as
が
well
予
as
定されています。
reported for the
ロードマップでは
greenhouse
2030年
gas.
代に
And in the
建築物
roadmap
LCA の
in
取り組みを一般化す
2030s,
る。また2040
this
年
has
代
to
に
be
は削減施策を
generalized
さらに
for the
強化し
entire
ていく
practice.
方
And
向性
also
が
from 2014
示さ
onwards,
れています。
there is the
日
directions
本でも制度化に向けた
set
検討が
for
本
the
格化し
further
ていますが、
strengthening.
欧州では
And there
国
is a
や都市によって
full-fledged
は
studying
2010 年
here
代
in
から
Japan
建
and
築物
in
LCA に
Australia
関
from
する取り組み
2010s.
が進められていき
There
ました。
has been LCA
今日お
related
話しいただくイギリスの、
practice
ロンドンの
underway
お
in
話
some of
が中
the
心になると
cities
思う
as
んで
well
すけ
as
れど
in the
も、
countries in
ロン
Europe.
ドン
And we
町
will
が
mainly
ホールライ
hear
フカ
from
ーボン施策の
London
ガイダンスを策
in
定したり、
the
ま
greater
た都市計
London
画であるロンドン
area.
プラ
They
ンで
have
は
came
ロン
up
ドン市長
with
との協議
the
対象となる
plan
大
as
規模
well
事業
as
の開発計画
for
に対して
certain level of
建
the
築物
development
の
a
ライフサ
project,
イクル
the
全体にわ
building
たる
life
カーボン
cycle
排出量の評価と
carbon
報告
emissions
を
have
求
to
め
be
ていま
assessed
す。
as well as the
こう
reporting
し
has
た
already
政策
become
の
the
形成や実務
mandatory.
の導入に大きな影響を与
Such
えたの
a
が
policy
建築不動
building
産分野
as
の
well as the
実務者や
practice
専門家による
was
活動です。
largely influenced by the activities
米国
undertaken
王立
by the
建築家協会の
practitioners.
リバ、実務者指導のネットワ
Riva
ークであ
Royal
るレギ
Institute of
不動
British
産建設分野の専門家
Architect
団体で
Rex,
ある
Royal
リックスなど
Institute
が
of
目標値
Chartered
や算定
Surveyors
書
have
を提
set the
出し、
target
政
as well
策
as
計
came
画
up
の
with
後
the
を指示し
assessment
ました。
method, and that has
つまり
been
イギリスでは行政
provided
からの
as a
トップダ
reference
ウンではな
material.
く、
In other words,
実
the
務者
top
が
down and
直
from the
接課題意識を
administrative
持
is
って
not the
ですね、
approach, but the
ボトムアップ
practitioners have
で、建築
identified
物
the
LCA
issues
の
and
普及
also
と
on
制
the
度化を
bottom
進め
up
てきた点
approach,
が一つ
they've
大きな特
been
徴だと
coming
考
up
えてい
with
ます。
this new system, which
本
is
日
a
は
major
イギリスから
characteristic.
政策や実務
Today,
のアドバイ
we
ザーに
have
加え、建
the
築物
expert
LCA が
from
実
the
際
UK about
の
the
設計プロセ
practice
スにどのように組み込まれ
as
て
well
きた
as
のかについ
how
て、
the
ロンドン
LCA
のア
has
トリエ店
included
で
in
サステ
the
ナビリ
architect
ティおよ
and
び
designer
環境設計のディレクタ
design
ーとして活
perspective.
躍されている
And we
南
have
さんにお
Miss
話を伺います。
Yuna
それでは
from the
皆さんよろ
Atelier
しくお
10,
願い
the
します。
Director of Sustainability and Environmental Design. Over to you.
Thank you, Sayo. Thank you, everyone, for inviting me to talk in this forum. As Sayo introduced, I am Yoonha Ri, um, and let me just yes, just to briefly introduce myself, I am a director at Atelier 10 in London, looking after the UK environmental team. And I have been practicing as an environmental designer for 18 years now, managing multiple complex projects and working on sustainability frameworks for various types of um, built environment projects in the UK. And also to just briefly introduce Atelier 10, we were founded in 1990 by Patrick Bellew with a focus on delivering high performance building design. And we have been working across all sectors to deliver world-class environmental solutions. Our vision is shaping a more sustainable world, and we work to build relationship with our clients that makes a positive difference. And the way we approach things is that we try to be delightful and show design leadership. We want to create this good relationship to move this sustainability agenda forward. And we integrate climate resilience and regenerative, cost-effective design to our solutions, and also involve innovative solutions for holistic, long-term positive impact. And we have offices around the world. I'm based in London, but we have offices in the US, in the Middle East, and in Singapore and Bangkok, and all the way to Sydney and Melbourne, covering most of the world for our projects. So today, I will be talking about the importance of embodied carbon in the context of the UK, and how the timeline of embodied carbon targets and requirements have evolved. As Sayo mentioned, there was a bottom-up approach for the professionals to set targets and also publish a lot of guidelines how to calculate embodied carbon properly for buildings. And I will also share some of my projects, how we've applied those targets and calculation methodologies for our projects and lessons learned from that. And then how, in the end, I will share what was the outcome of this Greater London Authority mandating the carbon calculation and reporting in London to a wider market. So why embodied carbon? So as you can see, the climate change is happening, and this year we have been experiencing this in the UK quite in a quite direct way. The heat wave. This is really unprecedented frequency of heat wave hitting London, the UK, and also wildfires happening in France and Spain. These are all related to climate change. And love this quote from the UN Secretary that we need massive fast track climate efforts by every country and every sector and on every time frame. And I think the UK is in the forefront of trying to tackle this in the built environment. And so I would like to share some of our experiences here um, in this talk. And yes, this opportunity to influence this climate change in the built environment, this window is narrowing quite rapidly, and there is this urgency of addressing this issue everywhere in the world. And we published this book called Invisible Architecture because as environmental designers, we work with something that's invisible, like the air movement for ventilation, the daylighting, and all the carbon issues that we deal with. It doesn't, you can't really see it. And as Paul Pinch said, if only carbon stank, we would have addressed this ages ago. But because it's invisible, we don't see the direct impact in our day-to-day life that much. It is that more difficult to address. And then there are two parts of carbon, as Sayo mentioned already, embodied carbon and operational carbon. And in the UK, in the beginning, we were only focusing on operational energy slash carbon through building regulation. It was in early 2000, 2002, where we have this Part L building regulation for carbon conservation of fuel and power was published and came to an effect and started calculating operational carbon for new building proposals to regulate that. But then this Part L only covered regulated energy, not really touching upon small power and all the unregulated load by building occupants. And that has been creating some performance gap. So whatever the carbon that was reported for building regulation and what the actual energy use of the built building had some discrepancies. And these calculation methodologies and also the certification schemes like neighbors that was introduced from Australia were introduced to the UK market to close that gap. And from 2021, from this new London plan, and now they are requiring all the major development to do a more holistic, operational carbon calculation for planning approval. Then, just to show you the trend of this grid carbon intensity. So for electricity generation, the carbon intensity has been reducing quite significantly. So from 1990, it has dropped by 70%, with more and more renewable energy introduced to the energy generation and therefore to grid. Just for comparison, I've just looked up Japan, and it hasn't been that much of drastic change in the grid carbon intensity. And also just comparing it to the UK grid, it's more than twice as high, which means that it has a lower percentage of renewable energy in the energy mix. And obviously, this grid carbon intensity varies day to day. So if you look at this app in a sunny day where there is lots of sun and wind, it can be as low as 86 gram per kilowatt hours, or it can be much higher in the evening. And that's probably why it is really difficult to rely on renewable energy. But we're still trying to increase the proportion of renewable energy in the UK grid. And there is a firm plan from the government to further go down as we reach 2050. The reason this is really important is because this is directly tied to getting to net zero carbon for operational energy. So the idea is to reduce energy consumption in the buildings by efficient and building design as much as possible, so that all the energy consumption can be met with renewable energy production. And that's how we define net zero carbon for operational energy. And this is somewhat quite closely tracked in the UK. And we, with the current trajectory, there is a firm belief that we can hit this target by 2050 for the building industry. That's why, and then that because of that, with the efficient building design, with the building regulation introduced 25 years ago, and also because of the grid being decarbonized, we are seeing that the proportion of operational carbon reducing and the proportion of embodied carbon increasing when you look at the life cycle of buildings. And more importantly, embodied carbon is something that we're emitting now when we're producing building construction materials, whereas operational carbon is what you emit every year through the use of electricity and fossil fuel in your buildings. So there is more urgency of addressing embodied carbon because it is the carbon that we are emitting while we're constructing buildings right now. And so this is a graph of cumulative carbon within the life cycle of buildings, 6 years of life cycle of buildings. And you can see that the proportion of embodied carbon will be higher if we just track, within this 5 years. And this is just a typical building, not necessarily efficient buildings. And what we are seeing is that with more energy efficient building and grid decarbonization, the proportion of this embodied carbon, especially by 2030, or even if we extend to 2050, it will be higher. So we enter this whole life cycle carbon era in the UK. And it was quite slow, gradual, but then quite sudden from 2017 onwards. So from 2002 to 2017, there wasn't much discussion about embodied carbon. But from 2017, as Sayo explained, Royal Institute of Chartered Surveyors launched this documentation with the step-by-step calculation methodology of embodied carbon. And lots of different professionals, starting from architects, started publishing targets, embodied carbon targets, and that we should set, and also calculation methodologies. So, Institute of Structural Engineers publishing their own documentation how to calculate carbon for structure, or Chartered Institute of Building Service Engineers publishing the documentation how to calculate MEP systems embodied carbon, and facade engineers as well publishing for facade design. And then also the government started to react to this and introducing, like Sayo mentioned, Greater London Authority mandating all the major development in London to be reporting, calculating and reporting embodied carbon for planning approval. So, but then I would like to highlight a couple of important documents that really set the scene within the UK. So RIBA, the Royal Institute of British Architects, published this document called Sustainable Outcomes Guide. And what it did was that it basically introduced embodied carbon target for different timeline. And also the targets getting more and more stringent as the time goes by, alongside operational energy and potable water use. And this basically focused everyone's mind to look at what this number means, and also adopting these numbers for their project briefs for the developers, and started monitoring against these targets, which is really important because you measure, then you can improve. So this was a really important step. And this London Energy Transformation Initiative, LETI, published this climate emergency guide. It not only set the numeric targets for different sectors, different building typologies like office, resi, and schools, it also shows some data, what the proportion of that embodied carbon is within the building, what are the important packages that you need to focus on, for instance, the superstructure being almost 48% of the total. So it basically educated a lot of professionals in the built environment in terms of embodied carbon literacy. And setting different targets for typology also helped because the approach and targets could be tailored to specific sectors. And what happened was that there was also in parallel a campaign from the professionals to basically create this embodied carbon building regulation called Part Z. So this is not a real building regulation document. It is a campaign. They kind of created this document and then started campaigning that we should start regulating it for buildings being built. And the House of Commons reacted to this. This is a really recent event in 13th of July this year. This embodied carbon in building was debated by MPs. And they refer to lots of these documentations from the professionals and also the campaigns that has been running for years up till now, and basically addressing the importance of it. Of course, there was no new regulation announced by the government yet, but I think it's emerging, and hopefully this will be addressed quite soon. And once this is adopted, it will change the industry quite significantly. So in terms of design, the whole life cycle carbon will become a core design considerations alongside cost and program. And this whole life cycle carbon analysis will influence concept design and optioneering and material selections. And there will be greater emphasis on refurbishment, reuse, and life extension because there will be a limit to how much embodied carbon expenditure then you can expend for building a building. So the importance of refurbishment will become higher. And then it will also change the supply chain because they will have to demonstrate that their materials that they're trying to sell are low embodied carbon. And hopefully it will have it will improve the skill sets and then also improve carbon literacy in the whole building industry. So Sayo, I think
ここでですね、ロンドンっていう
At
の
this
は、イギリ
juncture,
ス・ロンドンというのは、
no, London in
多
UK,
くの国、また、
so
日本と
many
ですね、全
countries
然
as well as
違う
with
状況がある
Japan,
っていうのが
the
今の
situations is
のお話
totally
であった
different.
と思うんですけれ
I'm
ど
sure
も、
that
ちょっ
you
と
have
休
come to
憩して
recognize that.
デ
Why
ィ
don't we
スカッ
take
シ
a
ョンを
short
少し
break
したいなと
this
思っております。
short break here to have some discussion here?
はい、この質問なんですけれども、
And I have a
多くの国
question.
ではですね、制度や規
Unlike
制
many
が
countries
変
where
化を牽引するんですけれども、各国の実
regulations
務者が
drive
制度化を待たず
change,
に
the
エンボディード
UK
カーボン
embodied
設計上
carbon
の重
movement
要
was
課題
led
と
by
して、
practitioners.
取り組むようになった、転機とか
What
背
was the turning
景に
point
はどの
that
ような問
convinced
題意識があ
architect
ったのか
engineers
という
and
の
other
を、
professionals that
お話
embodied
し
carbon
していただけ
needed
ま
to
すでしょう
become
か。
an immediate design priority? Could you talk to that point?
I think, yes, of course. I think, as the graph showed, that they recognize that embodied carbon is something they're emitting now and not just throughout the whole building life cycle. And then it's something that they can influence directly, more directly than operational carbon, because operational carbon will be influenced by the usage pattern, the building users, and many other things that's not under their direct control. But the embodied carbon is something that they can consider while they're designing and constructing for architects, structural or MEP engineers, and all the consultants working on building design. And that's what made them focus more on embodied carbon in the UK market.
Let
こ
me
の
ask another question.
急にと徐々にとして急に、突然に、エンボディードカーボン
Suddenly
が
and gradually, embodied carbon
実務者からそして、制作に、
coming from practitioners,
も始まったというところなんです
and
け
there
れど
has been
も、
some
民
moved
間のデ
in
ベロッ
the
パーは、
policy
こうしたエン
front
ボディー
as
ドカー
well.
ボンに関する要件に
Now, the private developers, how have they been responding to these requirements? Have they become a compliance exercise, or are developers now using whole life carbon assessment to improve project value and competitiveness?
So, because now, at least for the London projects, it is now mandatory to calculate and report embodied carbon for planning approval. They're responding quite quickly. And there's another part. Now that they have numeric targets, set from the professionals, they have adopted those numbers for their project briefs, and they're getting more and more pressure from funders. Because especially in the UK, quite a lot of big commercial projects are tied to EU taxonomy and funding green funds. So for funding purposes, they are trying to adopt, and also to attract tenants, because a lot of large commercial tenants are international companies with their ESG targets. So they're getting pressure from multiple directions, and they're being really serious. And one of the projects that I will show from British Land, which is one of the largest developers in the UK, they are basically tying project managers' bonuses to the embodied carbon targets that they can meet for their projects. So they are taking it quite seriously.
Thank you very much for sharing such very interesting point. Now, let us move on to the second half of the presentation. So could you please once again share your screen?
So with this, the new trend of trying to reduce embodied carbon, during design, we have to look at operational carbon and embodied carbon together at the same time. Sometimes there are conflicting items. For example, for reducing operational carbon, we want to have solar shading, for example, for building design, but that's additional embodied carbon expenditure that you have to take on. So these kind of things should be now looked into at the same time for a better outcome in terms of whole life cycle carbon and the building performance. The key issue when we started regulating this is that there was unclear ownership of the embodied carbon budget across design team members working on separate work packages. Also, there were limited visibility of carbon impact at the point of design decision making if you're not calculating it constantly for every step. So we've started addressing this issue, and also the government was also pushing for more interrogation. And this is another step that we have introduced, which is even before designing a proposal for new build. If there is an existing building in the City of London and Westminster, you have to basically assess different options with different level of retentions to understand the embodied carbon impact of demolition. And I think this is a really important step because this basically encourages you to retain existing buildings as much as possible and avoid unnecessary demolition if the existing structure is robust and sound. But what that means for designers is that you have to be involved in this optioneering, developing multiple options with different retentions to a certain level, so that you can compare the embodied carbon impact. And we now have to do this comparison. And as you can imagine, deep retrofit will always come lower than additional new build components and demolishing existing buildings. But we also need to look at is that all these opportunities for reducing embodied carbon of new materials, and then apply these optimizations. And some of the options are not available for retrofit. So when we map this optimization opportunities to different options, the result could be somewhat different. And this is what we report to the planning authorities for consideration. And this is how we look at what option is the best in terms of embodied carbon. And then we also plug in operational carbon component throughout the whole life cycle of a building and map it and with the prediction of energy use. As you can imagine, new building will be more energy efficient with a tighter facade and better MEP systems. So we consider that as well. Then again, with this optimization solutions, it's not always the case that deep retrofit is the best solution, because inevitably it will be leaky, it will have higher energy consumption throughout. So we try to map what's the payback period of this new building material expenditure. And we try to select the option based on this quite detailed analysis, even before designing a new building. And once you select the option based on this analysis, this is when we do a quite detailed embodied carbon calculation for different packages and understand where are the hotspots are for reducing embodied carbon for those different packages. And as I mentioned, the responsibility, assigning responsibility is quite important because when the embodied carbon number is just lumped together for the whole building, different consultants and different designers don't know what their direct targets are. So we break the embodied carbon down into different packages that are managed by different consultants so that they can own this target and then try to meet that target for their own package. So MEP designers, they will just take on this 89 figure and then design their MEP equipment to meet this target, for example. And within each package, we then identify what are the optimization options. And this is quite detailed analysis that we work with specific consultants, designers to flesh out. And then we put everything together into this waterfall diagram to show the whole pathway to lower embodied carbon building with all the different optimizations from different packages combined. And what we developed is this quite interactive waterfall diagram where you can sort by different parameters. For instance, it can be sorted by risk levels, and then so that we can prioritize the low risk items to adopt first, and then consider higher risk items later, or by cost band. So if those optimizing measures give you cost saving, it's no brainer, we adopt it. If it's cost neutral, again, we adopt it most of the time. If it has cost implications, if this very novel low embodied carbon material is more expensive, then those kind of things can be considered later. Or it can be sorted based on type. What should be discussed at design? What can be what can wait until detailed design for a material specification? Or what are the measures that we need to consider during construction? So it can be mapped it that way, or by responsible parties, so that people know what packages they're owning and what optimizations they need to consider. And packages, as I mentioned. And program implication. As this waterfall diagram shows, many of the measures don't have any construction program impact, but some of the measures, like introducing recycled content to concrete, that will have an impact on curing time, and that needs to be addressed and considered by contractors. End stage. So it's quite daunting to see all these measures all at once, but we can just focus on what needs to be addressed at what stage, and just focus on that, that needs to be addressed before concept design or before schematic or detailed design, and put a cost against it, and debate what are the design implications, do optioneering, and make an informed decision. And sometimes you do need to think cross-package, because we realized through working on multiple projects that there are sometimes direct impact. So this is an optioneering that we did in looking at both structural systems and MEP systems together, and created this matrix, because different MEP systems can only work with different structural systems, for example. This TAP system, thermally activated building system, is basically embedding water pipes into concrete structure and utilizing the thermal mass of the concrete to cool the building. And that can only work with concrete. And through this exercise, what we realized is that, compared to timber structure that we know as a low carbon solution, concrete structure would be much higher carbon. But if you look at this MEP and structure together, actually this TAP system gives you a better result than having timber structure with fan coil units, because fan coil units are mostly metal, which is quite embodied carbon heavy. And also, fan coil units have to be replaced every 20 years more frequently than the TAP system. So if you look at whole life cycle and the combination of the systems, sometimes you'll find surprises. And that's what we want to capture by doing these kind of optioneering and kind of parametric design calculation to reveal these, and so that the clients and designers can make informed decisions. And we do a lot of research for new products, new solutions, to make sure that we're at the forefront of this whole effort of reducing embodied carbon. And when we communicate to our clients, sometimes what we do is we layer cost implication and program implication into this waterfall diagram, so that they can make a holistic decision based on all program cost and carbon impact considered. And oftentimes we have a very long opportunities list and then put that into this traffic light system, so that we track what's adopted, what's not adopted, and if not adopted, why. And then also, if things need to be interrogated further, what needs to be studied. And during construction, what also happens is that when 2 or 3 different suppliers bid for large packages like concrete packages and steel packages, we require embodied carbon number of their design, their products, and layer those information over our waterfall diagram, so that this can inform the client in making decision on which supplier they go with, and what the carbon implication is for that decision. So this tracking continues all the way to practical completion of the building during construction. So through this process, what we've learned is that we now can drive the carbon agenda as an environmental designer, and work more like a project manager to make sure that the carbon discussion happens for every design decision making process. And we introduce our expertise in cutting edge technologies, and also work closely with cost consultant and contractor to also embed these cost carbon program impacts. And we basically empower design team by giving them the budget that they can spend for their own package and for them to come up with their own solution to get to the target that we set as a team. Sorry. And then also we give a clear pathway to net zero carbon with this waterfall tool. So quickly, lessons learned from this process. Again, this is this Finsbury Avenue project that we are delivering with 3XN for British Land. We've had a very clear embodied carbon target from the beginning. What we realized when we started tracking embodied carbon from very early stage all the way now, this is under construction, almost completed. We don't have that much data at the beginning, and setting the target at the time, we just relied on the benchmarking from REBA, that guidebook. But then we realized that we are not including many of the details in the goal setting stage that reveal that we have more materials in the building and the higher carbon. So will be always a gap. So we should be aware of this gap and try to benchmark and also include contingency when we're goal setting. And this is a good example. Intumescent paint, we never kind of consider that concept design, right? But it does have quite not insignificant embodied carbon impact, 3% of the total, that you don't even consider a concept. And the way you kind of change your structure and the actual area of the application of intumescent can have quite a material impact in embodied carbon number. So these kind of things, you cannot really capture a concept that needs to be kind of observed within contingency that you build in. And also design matters. You can really make a huge impact even before designing a new building. You need to consider what you can retain if there is an existing building. And if you're demolishing, if there is any opportunity for reusing those demolition materials. And then you need to consider how you can design cleverly or efficiently to reduce the embodied carbon of your structure or facade or MEP. And reduce any waste because that is also the big impact on embodied carbon. So any solutions for prefabrication and reducing with waste during construction should be considered. Once all these are considered, that's when you then start looking at low carbon materials. And then as a last resort, offsetting any residual embodied carbon. And we found out that height also matters because as the building goes taller, lateral stability begins to govern the structural system, and you have to put a lot more materials into the structure to keep it stable. And also core matters. As the building goes higher, the proportion of core gets bigger and more materials into the core. And whatever transfer structure that you introduce to the building will have a quite high embodied carbon impact. So when you introduce it, you have to introduce it based on absolute necessity. And when you're choosing different structural systems, they have their own limit how far they can go down in terms of embodied carbon. Of course, timber will go much lower than concrete or steel in itself. But then we also realize that grid size has an impact. And the more columns that you introduce with smaller grid size, actually in terms of the structural systems, it's more embodied carbon efficient. because it significantly reduces the beam sizes. And obviously, there are practical reasons why you cannot go to the lowest potential grid sizes, or you cannot choose certain structural systems. But considering these with the carbon in mind at a early design stage when you're selecting structural system, I think is now becoming a common practice. And also adding this carbon as one of the factors to consider in addition to floor height, area, or program impact. And through this exercise, we realized that by just simply changing the grid from 12 by 9 to 9 by 6, you can save 20% of the structural embodied carbon, which is huge. We unfortunately couldn't take this because of the tenant desiring, wider grid size for their use. But this was a quite interesting finding. Then form factor also matters. The more articulation in the facade that you introduce, there will be much higher embodied carbon. And that we've evidenced through our own projects. The higher form factor, the higher facade embodied carbon we achieved. And a lot of countries, Europe and in the US, they don't really calculate MEP in the whole upfront embodied carbon because it's just too complex. And there are so many different components in like air handling units or fan coil units that people think that it's almost impossible to calculate this. But UK, I think, is pioneering this, and we are now getting a lot of information from the suppliers and getting their attraction to do their own calculation for their products, so that we can just plug in those numbers into our whole building LCA. And as you can imagine, the quantum-based materials like ducts, pipes, cables take a large proportion of this embodied, this MEP embodied carbon package. So we need to think about efficient routes and reducing the length of these quantum-based materials as much as possible. And when we talk about timber, we always talk about carbon sequestration. Unlike many other construction materials where you start emitting carbon from extraction, what timber does is that the trees absorb carbon when it's growing, and up until extraction and manufacturing, it's carbon negative. That's why we say timber building is a low carbon solution. But what we need to watch out for is that so these are the CLT structure in practice. But what we need to consider is that at the end of life, what's the end of life scenario for this timber? If it's incinerated, that sequestered carbon directly goes to the atmosphere, and it will delay for the life cycle of the building, but it will emit directly into the atmosphere if it's incinerated. If it's reused or landfilled, that can delay. So when we're designing a timber structure, we have to make sure that the potential for reuse and remanufacturing is maximized. So yeah, we have to design in order to get to specific embodied carbon target. There are lots of components to think about, a lot of people involved to design cleverly with innovation and efficiency, and also research for low carbon solutions with material specifications. And one size does not fit all. For different building typologies, we'll have to adopt different carbon targets and approaches. And landscape helps. The more landscape you introduce, the more carbon sequestration will happen on site. And there are some tools we developed with a landscape designer to calculate this impact. It's quite high level, but this can inform the benefit of landscape in your design. So yeah, when you're selecting material, it's not just only look and the cost, then you have to consider there's a lot more things that you now have to consider, including embodied carbon, health impact, and the ease of disassembly for future reuse and things like that. So through this, since Greater London Authority introduced this mandate of carbon calculation and reporting, they haven't mandated a specific target number, but they just mandated calculation and reporting. And this is a study by Arab, and it's published to the public. It's called Embodied Carbon in Central London, that you can download. The finding is that from 5 years ago, when GLA benchmarked this 950 kilogram CO2 per square meter at that time as the average embodied carbon of commercial buildings in the central London, there was about 24% drop in upfront carbon just by mandating calculation and reporting. And so we see a good benefit of this carbon mandate in the market, and it is slowly changing the market in the UK. So what we're seeing, I'm sure that you know this golden triangle in decision making. You always have to think about time, quality, and cost, right? And now this is a great publication from the British architect AHMM. We now have to put carbon into this equation and make decision according to this carbon square. This is actually happening in the UK market. And I think this is a direction that we will all have to travel to fight climate change. So that's it. So for me, this is a quick conclusion. So based on this grid carbon data available, I think that reducing operational energy demand and decarbonizing the electricity grid in Japan still remains vital priorities because it's not low enough. But as the electricity grid continues to decarbonize and the building efficiency is built into new building, the relative importance of embodied carbon will increase. And the development of embodied carbon calculation methodologies, together with numeric targets and clear timelines from NGOs and professional organizations, really helped pave the way for mandatory embodied carbon reporting in London. And this introduction of mandatory embodied carbon reporting has driven the London development market towards low carbon construction over the past 5 years. And we've also realized that design matters. So all the efforts to reduce embodied carbon should begin with a retrofit first mindset, followed by designing and building more efficiently and intelligently. And the government top-down approach, including the requirement of, so this is something that I didn't touch upon, but beyond embodied carbon, now London is looking on circular economy and retrofit first strategy more seriously. Hopefully I can have another time to discuss this. But I think the main message is that there is still a long way to go to achieve the Paris proof target, and every country and every sector must accelerate climate action across all timescales. Thank you.
皆さんありがとうございます。それでは、
Thank you very much.
最後にですね、
Yuna-san,
もう少しディ
lastly,
スカッションをしていきたいと思います。ご報告の中でもですね、
in the presentation that
デ
you
ザインチ
made,
ームがそれぞれの担当
you
者
talk
が、
about design team as well
パ
as
ッケージに、
each
カーボン
person's in
の
charge
管
in
理をしてです
respective
ね、デザイン
package.
していくという
They
話だったん
manage
で
the
すけれど
carbon
も、
when
こ
they
の
are
建築
designing.
LCA の普及に伴ってですね、 建
Now,
築設
as
計者、
whole
工場
life
設計
carbon
者、 サステ
assessment
ナビ
has
リティコン
become
サルタ
more
ント、
common,
コミュ
how
ニ
have
テ
the
ィ、
collaborations between
設計設
architects,
計者の
structural
役割とか
engineers, and
連携っていうのがおそらくす
sustainability
ごく変わったの
consultants
では
change
ないかな
throughout the
というふ
design
うに
process?
思う
I'm
んですけ
sure
れど
that
も、
how they
そのような、
coordinate
そ
a
の
change
もう
dramatically.
1、2例を、どのように変化し
So
たのか
could you
を、
give us one or two more examples how the change has occurred?
So basically, I think historically, I think it has been quite linear process. Like for example, architects designing the architecture, structural engineers come in and make the structure work, and the MEP engineers come in to fit in their MEP design in the building. But it now has become much more integrative process, and much more collaboration is needed, because their own packages influence the other packages, and the decision that you make as an architect has a huge impact on what the MEP systems should be designed to. That upfront collaboration, even contractors, now they come on board at stage 2, like concept design or schematic design stage, to influence what's possible, what's not possible, what's the carbon expenditure of this decision, so that informed decision can be made early on. That has a quite high impact. Yeah. And of course, I think as an environmental designer, our role has become quite important at every stage. So we sit on every design making decision meetings and try to give them information that they need.
ありがとうございます。日本の方々にもすごく参考になったのではと
Thank
思
you
い
very
ます。
much. That was a very good point that you have
質問
referred
で終わり
to.
たいと思います。
Would be a
日本では
big clue for the
2028 から
Japanese
義務化が
audience.
始まるということですが、
From
ロ
2028,
ンドン
it
の
will become
試験を踏まえ
compulsory
て日
in
本で
Japan,
導
the
入
life
する
cycle
初期段
assessment.
階で、
So at the
様
initial
々な
stage
学
in
ぶべき重
introducing
要
the
な
life
ポイント
cycle
とか、
assessment,
避ける課
based
題につい
upon
てのアドバイス
UK
をいただけますで
experience,
しょう
if you could give us a good advice, what are the issues and what kind of solutions would be possible, please?
So it was a quite big undertaking for the UK market, and to a certain degree, I believe that it has slowed down the development of new buildings with this mandatory requirement, because it does take more time to get planning permission with the whole calculation. But then I think in the end, I think we come up, I think it results in a better result in terms of the building design, and also for the operation of the building to have a solution that is closer to net zero carbon. The lessons learned is that I think, yes, we do need to just start from mandating reporting and not just setting specific targets, because I think Japan market is different to the UK market for based on what where you source your construction materials from, and what is the power grid of that location. So the numbers from UK cannot be directly adopted in Japan, because it's all different. So we did have a quite long time of collecting that data first to set sensible target that can be achievable, but still pushing the professionals to, because if you set an unrealistic target, it just becomes not useful for anyone. So I think it is important to have enough time to collect meaningful data, and then setting targets should follow.
とても良いアドバイスありがとうございます。ゆな
Thank
さん、
you
今日
very
はあ
much
りが
for
とうござい
such
ま
a
す。
good advice, and Thank you very much for joining us today. And this is the questionnaire sheet for this seminar. And please scan this QR code and please respond by 11th of August. Your feedback will be reflected into the future seminar, or just your comment or the observation is very welcome. We love to hear from you. The next webinar series shall be the third one from the United States. We will invite the practitioner. And the date is Tuesday, the 1st of September 2026 from 9:30 to 10:30. Yuna-san, thank you very much for today.
Thank you, everyone.